All right, we are going live now. Let's see, we're here. And we'll just wait for some people to join us. Hopefully somebody will join us.
Doesn't matter anyway. Just
Doesn't
record it.
matter anyway. Exactly. We're doing this for ourselves.
Exactly.
Cool. So while we're waiting for people to join us, oh, we got a couple people joining.
You're going to
Yeah.
want to set up. I'll have to share my screen, check my font sizes, all that stuff.
Oh, yeah. Great. So I will give you permission.
And
So
buttons to press.
while Martin is getting all set up, I can talk a little bit about what we're going to discuss today. So as some of you know, if you've been following along with the past couple weeks of our live streams, I've been building a DJ application, and one item that's been coming up for discussion, or one item that gets commonly discussed in audio applications, is how do you refer to application state, and how do you inject this into your audio application. So an example, for instance, and I can share my screen here. So let me just share my screen so I can talk about this. Close out Discord. Is that we have we will pull up this JUCE application. So this is the DJ application I've been working on the past couple weeks. And for anybody that's joined in the past few live streams, you've seen that Marvin has been on the sidelines passing me some breadcrumbs and helpful hints when I get stuck. So a simple use case here is that we have this audio player. So pretty simple. Basically, we have one class that's a data class that controls when a file loads, if playing the track, stopping the track, reset the track, get the metadata of the tracks. Then we have this attached at the moment to a user interface, and this user interface just has some buttons that allow you to do these various things to this audio player. So playing, stopping the track, resetting the track. I'm just building here just to give you an idea of what we have at the moment. So yes, so we have a load, a play, and a stop feature, and a gain function. So we have these things, and then what happens is that we have some type of what I would call plugin or application state. So an example of this would be, is the file loaded? If the file is loaded, then we're able to play it or not. Is the audio player currently playing? And if it's currently playing, then maybe we want to stop it. So it's determining what is currently happening in the application at a given moment. So Martin has talked about some options about where this application state needs to reside, and that, in his opinion, the state should not reside in the data model, directly in the data model. So
I wouldn't go that far.
You wouldn't go that far. Okay.
What I want to say is that it's like there's that question of what's the best thing to do, and the answer is it always depends, and there's never like a best thing. You're just trying to work out what are the pros and cons of each situation I'm in,
Right.
and so what flexibility do I get, but what complexities do I add? And so trying to understand what are the options and where you can go from this situation allows you to understand how to either make something reusable or how to allow control to happen in a different way. And we'll see that in a minute. I'll share my screen.
Okay.
It should be this one. Has it got it?
Yep.
So how do I, okay, it's fine. So I've made a repository and it's got a whole load of different versions of this idea. And like I said, there's no, it's not like, it doesn't go from like, you know, worst to best. It just goes from different levels of complexity and arrangement that you can try and look at and understand, you know, I'm here, but I want to go somewhere else and I need to manage this stuff. So this is level 0 called the JUCE starting point, and it's pretty much where you are. And so in this folder, now also another thing we can look at later is every single demo is its own CMake based runnable app. So if you load it in like Sea Lion and you set this as your project, you can just run this. So if I set JUCE starting point, I should be able to actually run.
Martin is starting to talk me into the idea of converting the project over to CMake and finally embracing.
As everyone should.
Should I say embracing or enduring CMake?
It's fine once you get past the first 2 weeks, I think.
Yeah.
I think if you give yourself a couple of weeks where you just, you know, I'm going to endure the pain and feel completely lost, read a book about it, and then come out the other end going, all right, you know, there's some basic stuff that you can get, but we can get into this later. So every app I'm going to show does the same thing. And it's like your app, but without all the other bits. There's 3 buttons: play, stop, and load. And so these are the actions the user can take. And then here we're just showing what state the app is in. So is it playing? And there's a file loaded. So I press play, we're playing. Press stop, we're stopped. If I click load and choose any file, it doesn't matter. And it'll say we're loaded. And I can click load and I can cancel it. And so, so this is pretty much equivalent to where you are at the moment. And it also works in a very similar way. So in the main component, so I've called it an audio player processor, which is your data class. And then this is the view. And as you see, when we construct the view, we give it a reference to the player, to the processor. So if we look at the constructor CC, we pass a reference in and we'll keep a hold of it. We're also a change listener because the processor is change broadcaster. So exactly like in your app, when something happens in here, okay, it'll send a change message and then the view responds. So I'll kind of jump about a bit quickly. If you want me to just stop and concentrate on a piece, I will. So when the view gets a change message, it just calls an update function. The reason I do that, I call this another function instead of actually setting the view stuff directly here, is that you want to set the view to the correct state when it's constructed. When you add a change listener, you don't automatically get an event from the thing you've subscribed to. So you need to manually call this so that when the view appears, it reflects the state of the processor. And so again, then the state in the processor is kept in a state object. And it's right up here. It's defined in the same file, just a pair of balls. It's super simple. Then if you look at the actions you can take on the player, you can load a file, you can play, and you can stop. This is called, you know, from the process block method. And then these are accessors for the view or whoever cares to know what the state is. But all of the things kind of directly happen on the processor. It goes, so like when you request this, it just pulls them straight out the state, because they could just be balls in here. At the moment, there's not really any architectural difference between this being here and this being here. No one else sees this type.
Right.
So then
So
you
you're,
have, go on.
yeah, so there's nothing, there would be nothing wrong in theory, or it doesn't make a difference that you've pulled this out to a different struct than,
At the moment, it's entirely equivalent to having those balls inside. But as we move into the other examples, it's to make them more equivalent in, class and object structure, so that they're easier to compare.
okay.
Or maybe not, I don't know. The thing is, there's so many, at every stage, there's a ton of options. Some of them are equivalent, some are not. And it's just trying to work out, if I do this, what does it affect? And, a lot of it is just to do with experience and just trying to find the way to think about them. So if we go back to the view side of things, so this is state. We've seen, here we go, we've got accessors, there are a pair of balls. This is how we find out what the state is. But how do we change the state? How do we make this do things? So we have these action methods, load, and it just says state, is the file loaded? Does this file exist? I don't bother, loading WAV files or anything yet. Then you send that change message. Same here. Press play, state playing is true. Press stop, state playing is false. And also another thing to say about all of this stuff is there's really big topics to think about in audio development, like threads and how you get data, audio thread to message thread. I'm not looking at any of that because I think it's useful to understand at this level and then look at it at the next level of how would I start, making sure these things are thread safe or whatever. But we'll see one of the libraries has, options for thread safety. There was also another thing. Oh yeah, so persistence. I'm not going to look at how do you save this stuff, how do you load it again, how do you do that get state information, set state information. Again, it's another kind of big topic that you want to get a handle on when you're not thinking about 200 other things at the same time.
Yeah.
So, we're trying to draw these strict boundaries so we can keep an idea of what we're doing. So we have these actions, and we call those, and we can, at the moment, in this example, they're called directly from the view. And so we'll do this stuff. You bind a lambda to the on click of a button, and we've got a reference to the processor in our view, and we just call it. We call play, we call stop. And then for the file thing, we have the file chooser stuff in here. It's in the view thing. Open that up, launch async this, and then when we've got the result, pass it to the processor. So the key thing to notice in this example is the view is very tightly coupled to the processor class. It knows everything about it, and it needs all of this. It calls actions directly on it. It gets its state directly from the processor. So if you ever want to construct one of these views, you need to have a processor to give it.
Right.
Which means you might write this view to be a really beautiful generic transport view. Stop, play, pause, rewind, or whatever. And you're like, okay, this works brilliantly. And now I want to, excuse me, use it on my video player. Or I want to use it on a different type of thing that I can control in this way. But I have to use it with one of these because it's tightly bound to this. How can I reuse this visual component in another way?
Got it.
So that how do you decouple this type of view from this processor? And again, there's options. The first one, I would automatically think of, because I've done a lot of OO stuff, is okay, well, I'd actually make this inherit from some kind of base media player object, maybe with a load of pure virtual functions for play and stop. And then this would inherit from this thing, and it implement all these functions. That's one option. But then again, you're still coupling this to a particular type hierarchy. And you may find that later on, you want to change something. You have some feature that comes out of a subclass, but you want to represent it in this view. And then you're like, okay, so maybe in this view, I'll need to dynamic cast and check what type this thing is behind it.
Yep.
So there are other options. Anyway, so is this all clear, this example?
Yeah, this is clear. I actually have a couple questions that are very tangentially related. The first one is that I noticed that you're only including UI basics for this, which makes sense. Since it's Pragma once, does it really make, I guess it doesn't really make a difference, does it? That because your main component is already going to be having JUCE header, the main JUCE header, correct?
Because I
Okay.
use CMake and I
Uh,
don't generate JUCE header.
Got
I
it.
actually include only the module headers I need.
Okay.
So another advantage of CMake is it makes doing this type of thing more straightforward. And then if you do your own modules or whatever, you can track your dependencies more easily. And then
Got it.
I wouldn't know about the build system. We can ask Ben or someone else equally knowledgeable whether it makes a huge difference to build times and how much code gets compiled or whatever. But
Yeah.
it's just I think it's good to know what you're using anyway.
True. Yeah.
And also there's other considerations is that, again, really tangential is different parts of the JUCE library are licensed differently. So some of the real core stuff is ISC licensed.
Uh-huh.
And so if you've written some code and you're like, well, I'm only touching the ISC licensed JUCE stuff, that leaves me much more free to choose how I operate with this code. I don't need to buy a JUCE license. I don't need to make it GPL, all that stuff.
Got it. The second question is one thing that always go through, I always go back and forth over is just naming conventions. So I guess would view and processor be kind of your standard naming conventions, or like would you stay away from the way that I've named it, which is more like data and UI, or in the past I've done audio player component, taking more of the JUCE kind of naming convention.
I always struggle with this stuff myself. It took me longer to think what to call this than it did to write all the code in it.
Yeah.
My convention has been to call things that inherit from component views, because I just do, and it just kind of feels more natural than calling it UI, because you end up with that UI everywhere, and you're never quite
Right.
sure is it something that works with a UI, but does it show anything on screen? But I know anything called view is visible. And then I
Yeah.
might still call stuff UI if it's some kind of helper type or whatever that's involved in UI, but it might not be visible. This, I chose it purely because it's got the process method. And so it implies that it's something involved in audio thread work. So whenever I see this, I'm just like, all right, I've got to be aware that this will be running on the audio thread, at least in some methods.
Mhm. Would you say that a processor and a model, a data model, are the same thing? I mean, to
No,
me, I can't think of any
not
differences,
at
but
all.
no. Okay.
No. So to me, the processor is something that, like I said, will perform a transformation on incoming signals, and that might be MIDI, audio, and then it will produce some kind of related output, MIDI audio output. So it
Right.
processes stuff that comes in, typical to a plugin, and it transforms them and sends them back out again. Whereas to me, a data model is something more like the state, where I think of it as it's it's like it's more like a sheet of paper with stuff written on it, which describes like the state of the system. It doesn't do stuff, but it's
Mhm.
just like you can look at it and go, "Oh, right. So you're playing, you've got a file loaded, and it's sort of like information about what's going on, but it doesn't do stuff."
Got it.
So that would be how I struck. To me, model and data is always about like modeling those concepts.
Yes, got it. So that's more like the what's that old school diagram that
UML.
UML? Yes. So model is more like the UML. Is that would
Yeah,
that be
sure.
correct?
But saying that, obviously, everything that does this has a model.
Right.
There's some internal representation of the state it's in. So in some ways, they're not the same thing, but this always has this thing in it.
Mhm.
So this is it. I would always compose a processor out of a function that processes stuff and a model that represents the state of it.
Right.
So maybe that's the way to look at it: is processor is a function that's a transformation of MIDI and audio in whatever way, and then it's a model which represents a state of what it does. So that function is the key difference.
I see. Okay. Great. Yeah. So this is more or less what where my understanding is at the moment.
Yeah.
So okay.
And I think
Now,
this is, and also
yeah.
if anyone who's listening or watching this, whatever, don't get the feeling that, this is a bad place to be. This works and it does the job. And the most important thing when you're writing apps or code is, does it work?
Mm,
You know, don't shame yourself about like, oh, well, I've seen people do this and I've seen people do that. If you can read it and it's obvious and it works, that's as good as it needs to be.
yeah.
So the next, but what we're going to look at is these things. How could we make it so this view is maybe more reusable? And also there's other considerations is like when we write plugins and audio apps, we're not always trying to initiate actions by clicking on user interface elements. We want to map them to MIDI controllers. We want to have keyboard shortcuts. And so if you look at this structure like this, the question is, how could you introduce those types of responses into the system? And with this like this, it comes quite difficult. You might often hear people ask the question, how can I trigger a click on my button from MIDI? Whereas the way it's better to think about it is, how can I take that action that happens and make it respond to both MIDI and button clicks? I don't want to send MIDI to buttons. Instead, I want this action to be something that I can make happen through various signals, shortcuts, MIDI, button clicks, open sound control, whatever it is. So what we'll do is move to the next one. What did I put in the list? So these two are fairly equivalent. So I did two versions of the kind of the same thing. So the processor is going to keep being a change broadcaster. So let me use change broadcaster processor. But we're going to introduce like a middleman into the whole situation, which I've called audio player. So it's not the processor, it's not a view. Let me load this CMake project. And so what you can see now is instead of the view calling methods on the processor, this audio player object, it says when this on play thing happens in the view, and we'll look at what this is in a minute, we'll tell the processor to play. When on stop happens in the view, we tell the processor to stop. Same with on load. And then we also means this file choosing logic comes out of the view. So if you look into the view, that's the right one. Now it still has a processor reference, but the actions we've kind of abstracted away. And we're going to use the same style. So these are equivalent to the on-click methods you'll see on the button. But what I've done is I've assigned them to empty lambdas so that I don't have to test for null pointers when they're invoked. So let me show you that. So here, when we do on-click, we then invoke this lambda on play, which is something we can bind to from the outside. Okay, and we do this for all three things. We're transforming a click into a more semantically rich message. This click means play, this click means stop, and this one means load. It's not a big step from where we were, but as the application becomes more and more complex, it's much easier to reason about what's going on. So that's this part. So this pattern I do all the time when I construct views in JUCE. It's like, what events does this thing produce? What actions does it do? So, it will do play, stop, and load, or, you know, maybe it's something to, you know, you're doing the start and end point of a sample, and it will just be like a lambda where its start point changed, and you'll pass like a double for the position in the sample here. But the idea is to make your view produce stuff that means something in terms of the app, not just clicks. And this is where, so also now this means, because this audio player has a processor and knows how to tell it to do things, I could set up the MIDI stuff in here. I could set up the keyboard shortcuts in here. And they'll all be independent from the view itself. The view doesn't even need to exist. You know, so the MIDI CCs will still work or whatever. The rest is very similar. We've got a change listener, if, and we check the source and we update. But this time, we're actually accessing the state as its own object. So we ask the processor to give us its state. So we know even less about the processor than we did before. Let me open the old one so you can kind of see what I'm saying. So audio player view, maybe I can split this. So yeah, it won't highlight the one on the right properly, unfortunately, because it's not part of the project anymore. So if you see before, what did we know about the processor? We knew it had a method play, a method stop, method load that needs a file. We know that we can add change listeners to it. And we know that it's got this is playing a has loaded file. So we've got a lot of knowledge about what this thing does. But now, all we know is it's got change listeners, and we can get some state out of it. And then we can query that state. So now we've gone from this wide surface knowledge from view to processor to much smaller surface area, listeners and state. So what does get state do? It just returns this state object here. And all the rest of this stuff is all like what we saw before. And if we compare these files as well. So now we've got rid of these. We don't need these internal queries to get this out. We just need to pull the state out. And also in this example, if you notice, the state comes as a value. And what I mean by that is it's a copy of the internal state. It's not a reference. And so you're free to pass it around and copy it. And, you know, this gives you some element of thread safety. Once the processor hands you this, there's nothing binding it back to the processor.
Right.
You know, if you accidentally start mutating the state in here and you're like, oh, let me just, I mean, this might be a mistake that this might be a situation that mine might find frustrating. It's like, I've got this state, so I actually want to set playing to false because I want the processor to stop. So the downside of this way is you're more removed from the mechanics of what you're trying to display in the view and control. Because now you can't just do stuff to the process. Well, you could, but you wouldn't. Instead, you know, you have to communicate through these bindings and say, oh, I want this event to happen.
Right. So one is changing and the other one is just viewing the state.
Yes. So there we have the view now is more. So this thing, if we go to the main component, so also you see now, we don't construct both things here. You're just like, right, I want an audio player. I want it to process audio. I want it a view. So we construct it here. And then we can add and make visible the view. And then in here, we'll just say, well, process as well. So for in terms of the main component for the app, this is like its own contained component with all the stuff we need. So it's easy to kind of instantiate this and move it around. We don't need to construct it as parts and wire them together because this does that for us. So as you can see here, it's exactly the same that main component had. We give the processor to the view. And also the nice thing is this file selection logic is out of the view. When you click a load button, there's no reason for the view to know about file choosers and async and all that. You may have developed this, you know, amazing function that you use to like open a file chooser with right format selected and looks in the right folder that you've got from a saved location, and you have certain logic to handle return values. But a view doesn't need to know about that. You don't need to like start adding more dependencies to the view.
But normally I would have that in the processor. Because to me, I guess my thinking there would be that this is data, so it's not. So
but
it
it's
shouldn't.
not. The thing that comes out of this process is the data. The result of this process is a file. The process itself, this thing doesn't really care. There's no reason for this processor to care how it gets a file. All it cares is about, give me a file to load. Now, it doesn't matter whether it's come from a dialogue, whether you've loaded it from some saved state, whether it's come across a message across the network.
Got it.
Those types of things. So and also it reduces your surface here. If you start adding file chooser, then you've added loads of JUCE GUI stuff into your DSP world. So you keep this more clean. It's like a separation of concerns. What is this concerned about? Loading a file, playing audio. It shouldn't care about how the file is. Well, it shouldn't care about how you've chosen to load the file. It will care about how you load the file, you know, whether you're buffering it into memory or you're streaming it from disk, all that stuff. But it's about separating the process from the result of the process.
Got it.
So the processor
Yeah.
cares about the result.
Yeah. That's a good correction there. When you mentioned that the file chooser is actually a UI thing because it opens the dialog. It opens a dialog box. I've always thought of it as more of a data thing, but that's a great point.
And so that's basically it for this example. You can see it's very close to where you start, but you already, even just this small choice helps you look at your system in a different way, and immediately you're more ready for the future. Whenever, so you know, you're like, oh, okay, my processor is launching a dialogue, but now I want it to choose the next file from a list of files that I've got from recursively scanning a hard drive. Nothing to do with dialogues. And again, you'd want that outside of this. You know, it's try and just keep the jobs that things do very limited.
Mm-hmm.
Anyway, so this is this example. The processor itself is a change broadcaster, and the view is still a listener. But that means we're still bound to this as a type, even though there's only two things we care about. We just care, has it changed? And now what's the state now that it has changed? So we don't really care about the processor itself at all. We're just like, we want to change notification and we want a new state. And as you've seen, the state is this. So really, we want change notifications and a pair of balls. We don't want a whole processor.
Right.
And again, there's choices now of how you encapsulate that concept as something to give to the view. You could wrap them up. You could have well, let's go to the next example because it will show you one option. So the next one is we make the state a change broadcaster. So before the processor was broadcasting changes, and we're asking the processor to give us your new state. But what if instead we made the state itself the thing that lets you know it's changed? How does that look? So if we go to the view, now instead of giving the processor into the view, we give the view the state itself as a reference. We'll keep it as a reference here. We close that one, and the state is now the change broadcaster. And it also has, now that we've got to send notifications out of it, we've got a couple of methods for mutating the state, because we've got to know when these change to send the notification. If you just called this from outside, in fact, you know, you'd probably want to make these private and have get playing and get loaded as well. So you know that anytime anyone mutates these, the message gets sent. But I'll make a note of that, and I'll probably update this example.
Yeah.
So in the view, but it also makes the view slightly more complicated, because in the view, now I'll get a change notification from the state, and I call update, and I can just get these values straight out of the state. And this is where I said they should be accessors. So now this view knows nothing about an audio player data, audio player processor. All it knows about is the state. So anytime you'd want to implement any different type of this thing that can play and stop and say it's loaded, as long as it has one of these related to it. Well, let's actually see how the processor uses the state. So again, we've got this middleman, binds view events to processor actions. Same stuff. This is all exactly the same. Here, instead of passing the processor into the view, we pass the. You notice here we say processor get state. So the state belongs to the processor, and we've now got this accessor that gives a reference to the internal state. Okay. So there's not a lot changed, but we call this when we construct the view, and the view has a reference to this, which is the state, and then the state sends these change messages. The difference here, though, is that we have a reference to the state. It's no longer a value in the system that we can just pass around as we like, because change broadcasters are not copyable, because you'd lose. What do you do with the listeners when you copy it? Do you take a copy of the listeners? Do you delete them all? So these aren't copyable. So you've now lost the ability to have a bit of thread safety with these values of state. So instead of peeling off a copy whenever you want it, and you just send it to the message thread and go, I know I don't have to worry about the audio thread. Well, now maybe I do. Maybe, this stuff, because it's a reference to what's going on in the processor. I mean, look, it's a pair of balls. In this situation, it doesn't really matter. But as I start to have more complex data types like vectors or whatever, you might be concerned with thread issues. Okay, so are we all clear? Have you got questions? Anyone in chat got questions?
I'm not seeing any questions in the chat. This is really interesting. I've done this way as well. Just pulling the state out to its own place that's independent from both processor and the view. But this is very interesting. I'm curious to see. I'm in suspense of what the next
level,
of what the next iteration of this looks like, because
it gets better. So what's next on our list? So next is JUCE listener list. Right, let's load this one up. So we go to JUCE listener list, load that one.
By the way, if anybody has any questions, please feel free to chime in the chat.
So let's start with the player, and it looks almost identical to before. This will go away in a second. Let's have a look at the state. Now, in this one, where should I start? I think actually the best place to start would be looking at the view, because then you'll see, we'll work backwards. Why is it taking? Oh, it's having to download JUCE and then build it all. So the difference in this one, we're no longer just a normal JUCE change listener. We've created our own listener type, which means we can now have messages, notifications with a payload. It's no longer just something has changed. Instead, now we can get the actual value of the thing that has changed. So you'll see this more as we go on, is you can start to think of parts of the system as generating streams of events or values over time. So as your processor does things, it will send out a state saying, right, I'm playing now, and then I'm loaded now, and I've stopped now. But also similarly, if you look at that idea of values over time in the context of an application, that's how you start looking at undo. is if I record these things, well, I just go back through my recorded list and I put the state back to the thing I've recorded. That's how you start getting, history and time travel and those types of things. Anyway, I digress. So what we've done in the state, we're going to give it two internal types, which are both pure virtual. This is a listener that the view is going to implement, and the view is going to say, okay, when the thing changes, give me a copy. I want a new copy. And the broadcaster is the thing that's going to manage having listeners. So in the view, we inherit from the listener and we implement this method from listener. And so when we get this state change method, here's the new state. It comes right into the method as a value, and we just query it here. And so notice when we construct this, we don't need anything. We don't pass anything into the constructor, not the state. It just, you can construct this without anything else. It wouldn't, respond to anything, but it makes construction of these things easier. Obviously, there's wiring to be done, which is, this happens in here. How do you now connect? Let's have a look at the processor. So the processor is a broadcaster. And again, no constructor. We don't need to pass something into it to construct it. So they're both, the processor and the view are default constructible. But we have to implement these two things from our broadcaster interface, let's call it. We also have to do all of the machinery of listening. Now that we're not relying on the JUCE change broadcaster, we've got to keep our own set of listeners. We've got to have these methods. It's not particularly complicated. You can, copy and paste most of this stuff, out of the JUCE source code. I wish the Clang format didn't keep doing that.
What's the link to that repo again, Martin? GitHub.com
Normalized
normalized.
state view JUCE demo.
Okay, great. Great.
It's on GitHub, and I'm always on the Discord as well. So just, ping me in any channel you think's appropriate, and I'll talk about it.
Fantastic.
So in this situation, we've gained some things in that we can default construct those things, and we only have to implement this method from here, and we only know about state. We don't care about processors, but we've also had to accept the burden of implementing all the machinery of listening ourselves. And so this is one of the concerns I have when you only use JUCE, is to go from change broadcasters, which are very dumb, I've changed, waving your hand, but I'm not going to tell you what's changed. I'm not going to give you any information about it. You're going to have to ask who changed and then ask them what changed. Whereas here, I can now just send this directly. So here's the key thing. Any listener, I say, state's changed. Here's a copy of my state. And so in here, we set the state and we send the state change because we're managing the listeners. And the wiring between the two things is done here. Because this audio player kind of, I don't want to call it a component because it implies it's a JUCE component, but this audio player thing has both of those, and it says into the processor, add the view as a listener. And then when it dies, it says to the processor, You know, the view doesn't really care about what you're doing anymore.
Mhm.
Now you can see obviously that the processor lifetime isn't bound to the view lifetime at all. You know, the processor can be, so then if you're in a plugin situation, when the view's constructed, you just say to the processor, oh, tell this guy some stuff. And then when the view's destructed, you know, you remove it, but the processor's still processing in the background. So that's a typical plugin situation where, you know, editor may or may not be alive.
Mhm.
But it's all very similar to the previous things, but you had to write more code for seemingly little benefit.
Mhm.
But the big benefit is you get messages. I kind of call this a message where there's information inside it rather than a notification, which is like something's happened, but I'm not going to tell you anything apart from that.
Mhm.
It's like you've got an email is a notification, but this is actually the contents of the email itself. Is like, read this. If anyone uses email anymore. So these are all the JUCE only options. So we've started with what you have at the moment, processor view, coupled together. The view tells the processor to do stuff, and it queries the processor to when it updates the view. We've looked at processor being a broadcaster of change notifications. We looked at the state being a broadcaster of change notifications. And then we've also looked at the processor being a broadcaster of state messages with actual payloads. So then the next thing is to introduce libraries. This one is called Rocket, and it's a signals and slots library. Apparently, there's a huge amount of these things in the C++ land. What I will do is I found there's a GitHub repository which has a set of benchmarks that compares a huge amount of these libraries and measures them on various metrics of like how big is a message, what's the kind of overhead of a packet for a message, what's the throughput, how many can you send per second, does it have, is it thread safe options and whatever. You may or may not care, but we'll look at this one because this is the one I've used a bit. I quite like it.
The state management programmer.
And we're only just touching the surface here.
Yeah.
I mean, we're kind of getting into it, but you know, because there's someone on Discord. Hold on one sec. So it was Samathy. Okay, on Samathy on Discord. Also brought up a good point of like, what if your state is a really heavyweight thing, and that it's copyable, but you might not always want to copy it. You might want to optionally copy it. And so you could kind of combine the ideas we've shown where you send a change notification, but then when you ask the thing, you could ask the state itself for a copy. So you'd say, and one good example of this, I think, is a preset management system. So you'll see that typical thing, right? So you've got a bar at the top of the screen, the name of the preset, and when you tweak the controls, a star appears to show you've changed it. Now, for this star to appear, you don't care what's changed. You just want to know that something has changed. That's perfect for notification. But if you then press the save button on your preset toolbar, you want to take a copy of the state as it is at that time and then serialize it to disk or whatever. So that's a very good approach to dealing with that common plugin situation. Get a notification where you don't care what's changed, but you want to let the user know something changed. And then they might want to do something with the whole thing and just say to the state, right, give me a copy. I'll transform it into XML or JSON or whatever and just dump it to a file. And you could you could combine those ideas to do that. Anyway, into Rocket. So Rocket apparently is a header only library. I'm not sure. I don't have an example of how you'd set this up with a producer. It's probably not too complicated. You can probably just copy it into your source and include it properly. But I use CMake, and I also use a thing in CMake called CPM, which is a package manager. And there's a thing inside CMake called fetch content that's like native to CMake, and this is a wrapper around it. I find it's just the least mentally taxing way of getting libraries into my project. So this is how I get JUCE. It's literally these 3 lines just to pull JUCE from GitHub. This one is 3 lines, but you also pass an option just because you don't want it to build its own example stuff. But I had to construct the library for Rocket myself, make an interface library, add the include directories, and then I add it as a dependency here. So this might look scary if you never looked at CMake before, but it's kind of pretty common stuff and it's not hard to get into. And the benefit over the producer is it's just here. I don't need to click the cog, click that tab, look in here, paste a thing, save the project, reload it in Visual Studio. I just edit the text file, save it, and C-line reloads it, and it's off. So we've added the Rocket library with CPM. How does this make everything look? How does Rocket even work? So let me remind myself. Look in the view. We look in the processor, look in the state. So let's go through each header in turn and see what they look like. So here's a state, ultra simple. Back to the most simple thing possible, it's a pair of balls. Copyable, all that stuff. The processor, this is where the Rocket stuff lives, because the processor is the thing that owns the state, and it's the thing that knows when things have changed. It knows when the file's loaded. See, because you might call stop, but stop might happen later on. You might call play and it might cue the play, or it might already be playing. So this is why this knows about when states change. So here we have this thing called a Rocket thread safe signal, and it's templated with this type. And as you can see, this type here matches this type here. So this signal is like a function signature. It's saying that if you add anything to listen to these signals, it will call a function with this signature. And so for us to be able to listen to these signals, we've got this one method, and you pass in a lambda where the parameter is an audio player state. This is your listener is just a lambda function. So the thing you'll notice here, there's no inheritance hierarchy. No one's inheriting from anything belonging to Rocket. No one's inheriting from listeners. No one's inheriting from broadcasters. You're composing these things together, which means later on, if you want to do things with inheritance hierarchies, and I don't know if you've done stuff before, Josh, about pointers, references, values, object slicing, and all that stuff. And
Not object slicing. I haven't heard that term before, but pointers, references, we've covered that in C++ lessons with my son.
Right, right.
What's object slicing?
So object slicing happens when maybe I don't want to go too far off the track, and I do want to finish this before midnight. We'll do another one where we'll get into some like stuff like that. The object slicing is when you've got an inheritance hierarchy and you pass something by value, but for example, if I've got a function, right, I've got a type struct base, okay, and I've got a type struct derived, and it inherits from this, okay. Now, if I want to pass derived stuff around, I might, okay, let's say I've got two things, right? You know, thing two, right? That's also derived from base. But I've got this method. I want to pass these things in. Well, the thing they have in common is a base. But, okay, if I pass, so I can pass in a base pointer. Yeah. And I'm good. I can do whatever, you know, call whatever I'm going to do. Right.
Yeah, but you got a static cast if you're doing a derived.
Well,
Is that what you're going to
I
say?
mean, if these are virtual functions, right? This is virtual, whether it's pure virtual or whatever, and I
Right.
re-implement this here, it will still call the right one. And same if I use a reference, okay? If I turn that to a reference and I call this, I'm still going to use the right thing. But what if I do this? So if I pass something by value using a base type, what happens?
It
And this
doesn't,
is,
if it's derived, you've got a static cast. You've got to
well,
make
what
sure that
happens?
it's a thing too, right?
Well, no, you actually lose these. It slices them
Got it.
because this isn't a pointer or a reference. And when you use things by value, C++, you know, you've got to know the layout in memory of the thing to make room for it. But if I'm only passing in this, I know how this is laid out in memory. But if this uses more stuff, I've got, you know, right, and I'm going to use this inside one of my, you know, overridden virtual methods. But I've passed in a base, but there's no space for this to exist because the memory layout doesn't allow it. So what happens is you lose this and you end up slicing to the base class. Oops. So passing things by value can result in object slicing. Now, fortunately, and I'm, you know, again, there may be even intricacies involved here and whether you store a copy as a member, whether you deal with it on the stack. I'm not a real expert on all this C++ mechanic stuff. But I do know that the compilers will say, you know, object slicing may occur. And I do know that I spent 2 days searching for a bug in a code base that was an object slicing bug, where you'd look at the object under the debugger, and you'd look at the internal state, and you'd be like, well, 80% of it is fine, but 20% of it is just garbage, and I don't understand. I look at it the frame before, and I look at it in the call site. You look at it in the call site, and you look at it where the error happens, and you're like, well, why did I just lose 20% of my object? And it's because it gets sliced.
Got it.
Right. So inheritance is a really useful tool, but it's also has constraints, and it implies all kinds of constraints of how you're passing around, especially if you want to do things with value. And I think there's a really good talk by, I'm going to have to look up his name because I don't want to get it wrong. I think it's Juan Pedro Bolivar, but let me check. from sinusoid.es. I don't know.
Oh, Wampe Bolivar.
Yeah, so I all of his talks are really good, and he does talk specifically about I think it's called most valuable values or something, and why building systems around values makes them much more easy to reason about and handle complexity. If you're always worried about lifetimes, you're always thinking about lifetime management on top of what does the app do. And then, so obviously in Java, it's nice. You never think about it. Just like, well, the GC will clean up after me. But the difficulty of C++ is, we got to clean up our own mess most of the time.
Right.
Which brings me neatly back to the rocket scoped connection, which is an RAII type. So have you talked about RAII stuff before?
Oh, we've mentioned it in the past. Yeah.
So that means resource acquisition is
Initialization.
initialization. But I don't think it's a good name, because most of the time we talk about it, we're worried about what happens when it dies, not when it's created. It's like, so unique pointer, what happens when it dies? Well, the thing gets properly cleaned up and destructed. And same with this. So when I add this listener, I'm going to pass back what you could call a subscription. And when this dies, my subscription gets cleaned up for me. I never need to, it says no remove listener method in here. I never need to clean up after myself. I just kill this thing and it's cleaned up for me.
Right.
So if you look at the audio player, I call it here connection. So we say processor, add a state listener. And like I said, here's this function signature. We give it a lambda. So when the processor state changes, we get this new state in by value here, and we give it to the view. We say, hey, view, here's your new state. What does the view do with the new state? Well, it just queries it. And remember, the state here is just a pair of balls. So now we're modeling the state of our app in the most simple set of concepts possible. They're balls, they're ints, they're strings and whatever. There's a word decomplect. So to make something less complex. Actually, there's another, I don't know if you've heard of Rich Hickey.
I don't
He's the
think
guy
so.
who invented Clojure, the Lisp basing. And so he does a good talk about this idea where to complect means two things are tied together. And as you saw it at the start, our view and processor were very much tied together. And we're gradually picking these things apart. So there's nothing more simple in the world than this. So you can just keep a mental model of, I'm modeling my app with this stuff. And the same with the view. Now in the view, all I need to say is, oh, pass something in here and I'll redraw. And I just pass this thing in here. There's no listening. There's no removing listeners. There's no objects required for construction. It doesn't get much more straightforward than this. And this is very similar to the web technology idea where views are pure functions. Look at this, not to upset any functional programmers, but you could look at this as it's a close approximation of a pure functional. You pass a thing in and it does the same thing for every type of input. It doesn't really kind of, construct a whole new view. It mutates this, obviously, but it's simple. I've modeled this as a pair of balls, and now my view is, oh, is this? And again, we're sending these signals out here. And there's no rocket here. We just have one method to pass in state. Now, of course, you need to wire them together, which is, again, this guy, he's starting to, this thing's starting to take more and more responsibility. It's like, oh, let me put the actions together. Let me put the state management together. Let me do this. But that's good because then you have a place to look at the wiring of the app. You've separated the concerns with like view does view, doesn't do anything else. This guy is involved with wiring. The processor, it does the state stuff. And again, there's another level. You move this out of here. You know, where you put it is a choice. But apart from that, you know, you've got the DSP stuff here. And when you call load, you set the state. So let's look at how you construct the rocket stuff. So we've got this thing with this type of signal, and it's called signal. And so when I pass this lambda in, so if you remember, this is from audio player, this is this lambda. I just say signal connect to this. And I return this connection. Now, I had to split it like this because, again, if you remember in the earlier views, we called update here after we'd added the listener. So we get the initial, we reflect the initial state. We've moved that now to this side where we say that if someone connects, tell them what our state is straight away. And then we give you back a handle. And then if you look in here, this connection is just a member that we hold. And when this dies, this connection dies. We stop listening. The processor lifetime doesn't care. It's separate from all that. And anytime the state changes, we just call this signal. And in fact, there's a real...
Sorry.
Hello, Toast. Is he okay?
Yep, all good. Just the dog. She's a rescue dog, so she always fusses when she sees other dogs in the window.
So do I. Yeah, so you see with the rocket thing that, like I said, we've got rid of inheritance. We've made the view really, really straightforward. The state is super straightforward as well. And we've just got a bit of, you know, connection handling here. And we've got a bit of wiring here. I mean, the wiring is literally just this. When this happens, we, you know, direct it onto this. You could, I mean, you probably don't even need the middleman. You could just, you know, processor add state listener, and then, you know, use the standard bind or whatever to this method. But it's more obvious here what's going on. And you can also, you know, reuse it in different ways or whatever. I mean, also that, you know, we'll see in RX in a minute. In 9 o'clock, we're okay.
Yeah.
So if I was building, and I am building JUCE plugins, Rocket would be my choice for doing this type of work. Or at least an equivalent signals and slots thing, because I get RAII management of listeners and subscriptions. I get zero impact on my state and my view from the library I choose to communicate. I get a very, very simple interface, and I get, you know, value-based, almost pure functional view updates. And so also the other concept from the web stuff I think is good to think about is the unidirectional data flow, which I don't know if you've heard about that either.
I've heard of that, yeah.
So we get that. What that means is everything just goes in a big circle, and it's a bit like model view controller. I mean, you could look at this. You can actually look at this system as an MVC type of thing as well, where this is the view. When this happens, all right, well, this is the controller in a way. So when the view says this, the controller says to the model, which you could say, see, the other way of looking at this is you actually mutate the state and then the processor listens to the state and then responds accordingly. But I think it's more that the state reflects what the processor's doing rather than the processor responds to changes in the state. If you see what I mean. So yeah, Rocket, I think it's brilliant. Really, once you've used it for a couple of minutes, it's pretty straightforward, and it does loads of extra cool stuff that you can choose to use if you like. So here it is, // rocket, single header. All right, so yeah, literally you can just stick that in any JUCE project and include it and you're good to go.
What's the license on that?
It is, I can't even see a license. Public domain.
Oh, cool.
So absolutely zero license. Yeah, public domain. So totally unrestricted.
Do you think that there's any concern in the fact that now your processor has this new dependency?
On the Rocket stuff.
Right.
Like I said, you could move it out.
Okay.
But the reason, like I said, the balance is you put it in here because the processor knows when it's state changed and it can signal state changes. But if you move this stuff outside, I mean, well, look at it this way. You could perform the same approach with the view where you have these lambdas that are invoked when something happens. And you could do this to the processor where like you have these lambdas you bind and the processor will call them saying, my state has changed. Here's the state. And then this thing does all the Rocket stuff. But the key thing is, like I said, there's no inheritance. Although it has a dependency, it's not an inheritance dependency. It's composed of this stuff. And whether you choose to hide it in some other part of the system, that's fine. But you're still, in these things, they're still copyable if they should be copied or whatever. So the other cool thing with Rocket is you get both a thread safe and a thread unsafe version. Actually reminds me, I saw Timo posted an interesting tweet today that he's got a new toy in his library. So it'd be cool to look at that at some point as well, because it's related to this stuff. How do you do thread safe communication? And his is about like it's like the writer is wait free and lock free, and the readers are lock free but not necessarily wait free. So you have a single writer, multiple reader. So I think that would be a very cool thing to look at. But yeah, the Rocket thing's got good docs. How do you do your first thing? How do you just bind straight to a method on a class? Pure virtual interface methods, handling lifetime and scope. So like the scope connection thing I showed you, well, if it dies, it's tied it up. Advanced lifetime tracking. I'm sure it's useful for some people. I'm not sure I could ever think of a situation where I'd really want it, but maybe there is. Getting return values from a call to signal. Now, this is very interesting, where you can collect values from the things that have received your signals. So if you notice in the JUCE, in all the JUCE listener stuff, there's no sense of return types. There's no way for information to flow back through these things, which then maybe you may want these back channels to not necessarily communicate actions and state mutations, but you may want, it may be a good way to collect information about the state of the system or different types of things. So I should think of an example where that makes sense. But this thing here, this could return some value if you wanted to do. It doesn't have to be a view, but You send out a signal, send out some data, the things at the end will process it, send you back a value, and then your thing that sent out the signal can collect all these values. And then you end up with it's like a distributed processing system. You just but you get non-inheritance based lists of stuff that you can collect values from, which again I think is very cool. Aborting emission of a signal, so you might want to stop. Maybe you want to send out something about a sample, but the audio driver's just crashed, and if you send a signal out, then the rest of your app's going to crash, and you want to recover safely. Queued connection. This one's very interesting. So you can build a message queue between threads, and that's something that's very common, required when we do plugins. Is how do I get complex, non-automated parameter data from one side to the other? How do I send metering data? How do I send, FFT data around? How do I tell the processor, like in our example, for example, the UI selected a file. Now in the real system, you're going to want to load that data on a background thread, and then when it's ready, pass some handle to the processor so it can actually work with you don't want to load it on the message thread because you're going to lock up the message thread. Your GUI will hang, and hosts, and you might notice the host UI slows down. You don't do it on the audio thread because you'll get, gaps and whatever. So having these types of things where you can do, and there's a really good example here. They show it in terms of a game engine where you're loading a 3D model, and then the rendering thread, finally gets a message saying, oh, the model's loaded, now I can draw it. Exactly the same stuff with loading audio files. 100% identical. And then intervals, timeouts. So that's why I'd recommend this, because it's easy to use, single header, and it allows you to decouple all of these things just for the sake of learning a little bit of syntax, and you get scoped handling of whatever. So the last example is RX. And I only want to talk about it briefly because it's the most complex, not in terms of implementation, but of what it can do. An RX is a reactive streams or reactive extensions, and it's a library for composing asynchronous and event-based programs using observable sequences and link-style query operators. So you can tell just from what it's called, it's not simple.
I thought you were going to say you can tell from what it says that it is simple. I was like, really?
No, and I've used this a lot. I've used it in JavaScript. I've used it in C++, and I find it's always mind expanding to use. But when you get the hang of some of the concepts, it solves some really tricky problems in a very concise way, but not an unreadable way. So I don't want to get into it because this could go on for hours, this stuff. But let me just say that what I said earlier with the idea is when you're broadcasting these messages, you think about them as like, this is data occurring distributed over time. And this takes that idea and it allows you to apply processing like a pipeline to that stream of events. And so they'll have things where you can create these streams, whatever, sending out, you can transform them. But the most interesting one is filtering stuff. Is like, let me open, I don't know if I implemented any in the RX, probably not. Let me just load it and just show you the setup, and then maybe try and explain one or two situations. And like I said, I use RX all the time, but it took me a long time to really wrap my head around it. And situations I've really found it useful is where you're trying to run services on background threads, and you just want to feed in, for example, if you have a drum machine, okay, and each pad has a sample, and the samples are going to be stored in memory. You're not streaming it from disk, and you load a new preset. That means you need to load in all the samples for the pads. So some system, say an audio file loader service, needs to be told, load me these 16 files. Then, whilst as it does this stuff, it needs to be communicating back to the rest of the system. This file's loaded, this file's loaded, this file's loaded. But also you want to know when that batch of stuff is complete. But also you might be this pad, your pad number 8. I only care about sample number 8. So I want to know when this happens. So I'm going to filter this event stream and say, if you're sample number 8, I care, but I'm going to ignore the rest. Now I'm going to be a different part of the app, and I'm going to observe the whole event stream and say, when this event stream completes, I'm going to, hide a dialogue. I might be a progress dialogue where I care about every single event happening. I don't care what's in it, but I care, has it happened? How many have happened? And what's the total amount that's going to happen? And so you can build all of these pipes with RX from a single event stream. So this audio file loader is just pumping out things and file loaded, file loaded, file loaded. And you have this RX pipe on the other side, just, things connect to it and go, all right, my file's loaded. And this one's going, oh, 7 out of 10 have loaded. And this one's going, all right, everything's loaded. But then there's another one who's looking for errors, and he's like, oh, there's an error. And so you're able to encapsulate all of these different types of views of the data stream using RX. So let's close these files. And and it looks very similar to the Rocket. The only thing is we don't get RAII management of subscriptions. We have to unsubscribe ourselves. But look, this code here is 99.9% identical to Rocket. State, same thing. View, same thing. I mean, these are literally the same code. There's nothing changed between RX and Rocket. The only thing that's changed is the thing that generates the event stream. So instead of a signal, RX has this thing called a subject, and we tell it the type of data we want to, excuse me. We tell it the type of data we want to spit out. And again, this is almost the same. This part of the signature is identical. We just return back a different handle. So at this level, Rocket and RX are pretty much a kind of drop-in replacement for each other. It's, we just have to do a little bit more hoop jumping here. We call this a little bit different. RX is always, there's a little bit more to be done. But again, we have the same benefits as Rocket. We've got no inheritance. We don't have to rely on any inheritance structure. We compose things. We manage, we manage the lifetime of these things here. We can start and stop them. And the state's all independent of it. But the interesting thing, like I said, is when this thing, it's observable. So maybe I only want to listen to when stuff's loaded. And I mean, this isn't good, but I'll just do it for the sake of it. So if I get this observable, let me put that back. So I'll say my observable is this thing. You'd normally be doing this outside of the state provider, the processor, but just for the sake of, now when I press this is all the stuff I can do to this stream. I can map it. I can merge it with other event streams to combine them into one. I can filter. I can even control which threads things happen on. And so going back to the audio file servicing, this is something I have built using RX. You can say, I'm going to observe the data, but when you tell me it's changed, I need it to happen on this thread, regardless of which thread it came. And you can, so you can have the thing, when you pump in the data, you can pump it in from any thread whatsoever, but you have a background thread running saying, okay, I need to be notified on this thread that this data has come in. So I'm running on the background thread. And also then when it sends it back out, you can have your processor say, only tell me on the audio thread. And the UI says, only tell me on the message thread. And you encode this stuff into the system itself. But it's complicated, like I said. But the cool thing is, you can just filter. So in here, you put in what's called a predicate, which will be with a lambda, and this is an audio player state. It's probably a const reference, I guess. And you want to return a bool. Should I keep this thing or not? So, if state dot is playing, return true. You can obviously just return state is playing. So now, if I subscribe to this filtered set of stuff, I'm only getting events when it's playing. So, for example, in your DJ thing, when you want to spin the wheel to represent progress through the track, you might only care about that when playing is happening. If it's stopped, you don't need to update the wheel to animate it because it's not moving.
Right.
So you can filter out those events as part of the stream. And again, the cool thing is these observables are objects you can just pass around.
Wow.
You could give the observable to the view and say, here's, if you look at this thing, it's going to give you a stream of data, and the view will be like, oh, cool. Let me filter it for this, this, and this. Let me merge it with some other things I've got. And so the nice thing with views merging multiple state streams is then you can reduce the amount of repaints you do. Because you might have a complex view that needs to listen to different parts of the system. I think that's enough.
Whew. I know that you blow my mind away with this. Yeah. Wow. And I think you've mind blown everybody in the stream.
Only me and you left. Everyone's gone. It's like, I can't handle this.
This is great though. This is great. This is all the stuff that is great to know, but is a little bit more dense than what I discuss. But these are the things that I'm trying to get to know to help expand my skill set. And this is great. This is awesome. And it feels like if nothing else, this is a good exercise just to try to implement each one of these systems and take a look at the advantages and disadvantages of these, look at how they're set up, and
yeah,
it feels like a good exercise.
Yeah, because you see that you're always fiddling with the same kind of parts of the system. Am I inheriting? Am I dealing with the machinery of observing values? Do I need some other guy to wire them together? Have I put the wiring all in its own place or whatever? So, and also cool. I wanted to get this done, so we've got a good reference.
Yeah, this is great. Yeah,
there's a repo, fantastic. And then we can always come back, and I don't know whether we can put chapters on the video or whatever. So you can kind of link each example to the chapter in the video and monetize it and make us both rich.
That's right. That's right. $1,000 a day. Cool. Yeah,
Cool.
if anybody has any questions about any of these approaches, please feel free to chime in the chat. I've put a link to the repository as well, and I'll put that in the description, in the video description. Yeah, thank you very much, Marvin.
Yeah, yeah,
Martin.
welcome.
I keep switching between Marvin and
Yeah, it's all
Mart.
good.
But this is good. This is educational, and this has definitely encouraged me to take another look at the way that I have state set up in the DJ app, and make some decisions on how much I want to decouple those things.
Hmm.
I've always had an aversion to external libraries, but maybe it's time to. I mean, they're there to be used, aren't they?
Oh, for
So
sure. And then people have done all the heavy lifting, there's a thread safe version. There's an example of doing message queues between threads for exactly the type of work we do. So, we don't need to keep reinventing all these wheels. And especially if it's a single header,
yeah,
just dump it in your source. Like, I mean, Rocket couldn't get any better, could it? Public domain, single header, loads of cool stuff. And then, when you're feeling really excited, have a crack at RX.
whew, yeah. Cool. With that, we'll go ahead and let everybody go and have a good morning, afternoon, or evening, wherever you may be in the world. Um, any questions, please? Questions, concerns, or improvements or things that you've come by that can help out with these workflows? Please feel free to put them in a comment.
My last thing
Yes.
I want to say, I will add more, and there's an infinite number of these things. Elanda, if you listen, I did start trying to implement your library. I will finish that example. And as I said, from Samithi's idea, I do want to add an example for his as well, because I think they're all valid things to look at. And also, there's even my library in here that I didn't look at.
You got a library for this.
Yeah, yeah.
Oh, wow. Nice.
But we'll do that another time.
Heck yeah.
And it's probably more interesting to look at how I implemented the library to kind of prove a concept rather than what it does.
That sounds great.
Cool.
Cool. Thanks again. Thanks again, Martin.
You're
And with
welcome,
that,
mate.
yeah, we'll be back probably later on this week with another live stream where maybe I'll implement some of these things. Thanks to everybody who's joined, and hopefully this is helpful for some people looking to solve some of these same problems. And we will see you next time.
Cool. Take care.
Cool. We're off.